What's up, guys? Today we're going to be solving 347 top K frequent elements, which is a very popular question that's part of many lists, such as like the Blind 75 list. That's also reportedly been asked by many top level companies like Amazon, Google, Microsoft, and all the other fan companies. So it's very important to go ahead and understand the most optimal solution. All right, so the whole point of the question is to go ahead and find the top K most frequent elements. So given K, you have to go ahead and find the most frequent element and in this case, the second most frequent element as well, up until you get to K. So in this example, we would have to return 1 and 2. The way we go ahead and do this, and no matter what, you should be thinking of making a frequency map. A frequency map is basically a hash map. We would go ahead and map the key, which is the number in our case. So for example, 1 would have a value of 3 because it has a frequency of 3. All right, so now that we have the frequency map, the natural instinct would be to say, why not just sort everything and then return the K most frequent elements? The reason why we don't go ahead and do this is because it would lend us a solution that would be an n log n time, because in worst case scenario, sorting everything is n log n, which is not that good compared to the solution that recruiters will most likely look out for, which is the linear time solution. The way we go ahead and achieve a linear time solution is by using a bucket sort algorithm. For our case, the bucket sort algorithm will basically look something like this. So the indices will go ahead and represent the frequency of the element. So at the first position, we're going to have all the elements with a frequency of 1. At the second position, we'll have all the elements with a frequency of 2. So in our case, we're going to go ahead and take our frequency map and map it into our bucket sorting algorithm. So for example, here we have the number 1 with a frequency of 3. So that means we're going to go ahead and go into the third position and then fill in the bucket with our number 1 because it has a frequency of 3. We go ahead and do this for every single element inside our frequency map, giving us something like this. Now, you may be asking yourself, why would we go ahead and use arrays, right? And that's because we need something that can store more than one number. The reason being is, what if we have 10 numbers with the same amount of frequencies? Then we would need to go ahead and have the ability to store them. So that's why we use arrays for the buckets. And this is really fast because mapping everything from the frequency map into the bucket sort algorithm takes n time. And then to go ahead and find the K most frequent elements, we just go ahead and go backwards. Our number for K is 2 in this case, so we start off here and we basically just append the value 1 to our answer. And then if it was longer here, we would go ahead and travel through the entire bucket, but since it's only 1, we move on to the second position, which is 2, and we just, again, we append our value to our answer array. And then at that point, we realize that our length for our answer is 2, which is equal to our value of K. So at that point, we return because we've already found the K most frequent element. And that's about it. Creating the frequency map is n time. Then mapping everything from the frequency map to the bucket sorting algorithm is n time. And then going back to find the K most frequent elements is K time. So worst case scenario is linear time. All right, so let's go ahead and look into the code itself. So first of all, I'm using counter from collections, which is basically a fast way of creating a frequency map. We could super easily do this manually, but counter is just a faster way of doing things. So I used counter in this case. The second thing we have to do now is create the buckets. We need n buckets because in the worst case scenario, we're going to have to need n buckets. Great, so now that we have n buckets, we got to go ahead and actually populate these buckets using the values from our hash map, which is the frequency map. Now that we have our bucket sort algorithm set, we need to go ahead and now loop until we find our K most frequent elements. And really, that's all it is. So this is the kind of runtime score you can go ahead and get in LeetCode. I'm pretty sure this is because we're writing it in Python, but nonetheless, this is a linear solution, which is better than the other options that we've shown before. Guys, if you found this helpful, please leave a like and subscribe, and tune in for the next one.